and how to do these kind of problems. Okay, let's do another one. A mass of 2 grams located in a region of uniform electric field 300 Newton per coulomb I carries a charge Q. The mass released from rest at x equal to 0 has a kinetic energy of 0.12 joules at x equal to 5 meter. Determine the charge Q. Okay, well, we have the mass of the object is 2 times 10 to the negative 3 kilogram, that is 2 grams. Its kinetic energy, well, let me see if I can draw that for you. We have an object that carries a charge Q released in an electric field. Look at that. This is the electric field. And this is the object that carries a charge Q. And assuming that the charge is a positive charge, it's going to experience a force in the forward direction, in the direction of the electric field. That means as it moves, it is going to acquire speed. And that is why it has kinetic energy. Now, when it moved through a distance of 0.5 meter, it acquired a kinetic energy of 0.12 joules. Okay. We have kinetic energy is 1/2 mv squared, so we can find the velocity. Now, therefore, what is v equal to? V squared equal to 2k divided by m. We know the kinetic energy, we know the mass. Using those values, I get v squared is 120 meter per second squared. And we will now carry the value of v squared. Now tell me, if you know the value of v squared, can you find the acceleration of the object? Well, when the electron came out here, when the object is here outside the field, its velocity is 0. Now, after it traveled a distance x equal to 0.5 meter, the v squared here is 120. Alright, we know the distance it traveled, and you know the initial velocity, you know the square of the final velocity. Is there a relation connecting initial velocity, final velocity, displacement, and acceleration? Yes, we have. We now find the acceleration using the relation v squared equal to v0 squared plus 2ax. That's the relation. v0 is 0. Therefore, 120, v squared is 120 equal to 2a times x is 0.5. And I can now calculate the acceleration. Therefore, a equal to 120 meter per second squared. You see how we started with kinetic energy. From there we calculated v squared, and then we used that to calculate the acceleration. Now, if you know the acceleration, we can now find whatever we are looking for. What are we looking for? Well, we're looking for that charge Q. We know A equal to Q over M times E, or Q equal to A times M divided by E, and we have all these values. A is 120 meter per second squared, and mass is 2 grams, 2 times 10 to the negative 3 kilogram, and E, the electric field, is given to us is 300 Newton per coulomb. Therefore, Q equal to 8 times 10 to the negative 4 coulombs. That is 800, no, not nanocoulomb, it has to be microcoulomb, because this is 10 to the negative 4. That will be 800 microcoulomb. That's right. That will be micro. Okay. Well, I think that should be enough. We have done a number of problems in calculating electric field intensity and force experienced by a charge in an electric field and calculating the acceleration and so on. Well, we are going to use all these concepts in our next lesson. So you cannot forget these. All right, review the homework. Now remember, the more you understand the earlier lesson, the better will be for you to understand the lessons that is to come. All right, so I hope you will come prepared for the next lesson. I will see you for the next lesson a little later.